Friday Happy Math Hour. We're going to review for your exam for today for your math 2412. So let's go ahead and get started. So the sections that we're going to go over today are sections 10.2, the parabolas, 10.3, the ellipses, 10.4, hyperbolas, and we're going to review converting from polar to rectangular, and we'll go through parametric equations. All right, so let's get started. So the standard equation of a parabola are given by these formulas. Okay, so we have a vertical axis formula and we have a horizontal axis formula. So it's very important for us to know which is the direction of the parabola. Hence, that way we have the correct notation. Okay, so a few points to look at when we're looking at the vertical axis. Okay, we when our P, which is our focus, is pointing, it's greater than 0, it's opening upward. When P is less than 0, it's pointing downward. Okay, so our vertex is our H and K, and we have a directrix. Okay, the directrix is equal distance from from the vertex to the focus. Okay, so the vertex is going to be found in the middle or the center between the focus and the directrix. And this is another way you also can find out what type of parabola we're looking at, if we have a vertical axis parabola or a horizontal axis parabola. Okay, so again, very similar for our horizontal axis. Okay, and it's very important that we know which is the direction of a parabola in order for us to get and use the right formulas. Okay, so I will be using the vertical axis as equation 1, and whenever I have to use the horizontal axis, I'm going to refer it as 2. Okay, so let's get started. So this is from your homework. This is problem number 29 from chapter 2. It says find the standard form of the equation of the parabola with a given characteristics. So the characteristics they're telling me is the vertex is at 6, 3, and I have a focus at 4, 3. So the first thing that I need to do is find out what direction is my parabola. Yes. So here, is it the vertical or horizontal? Is it 1 or 2? So hopefully we see that it's 1, right? So when we are using these two equations, we want our values that repeat, right? In this case, we're going to use, equation 2. K is the repeat, so we're going to use equation 2, right? So let's go ahead and get started. So my vertex here is at 6, 3, okay? And now I need to find my other elements from my equation. So from the vertex, you see that I can get the H and K values, yes? So once I get my H and K values, the focus, they're telling me that the focus is 4, 3. So this, and there's a formula to find my focus, given that H plus P is equal to K. So let's find out what P is. Yes, so P in my case is, given what I have, H is 6, I know that the value here is 4. So solving for P, I'm going to get P is equal to negative 2. So now that I have P to negative 2, again, it's just plugging into the formula. And we do a little simplifying, okay? And we're going to get our answer as this. Y minus 3 squared is equal to negative 8, x minus 6. All right, so let's look at this next problem. It says find the standard form of the equation of the parabola with the given characteristics, focus at 0, 0, and directrix at y equals 8. Okay, so again, we want to find a solution. Again, we want to find out which is the correct formula that we need to be following. Okay, so is it 1 or 2? So when my directrix is y equals 8, okay, this means that I have a horizontal line. So since I have a horizontal line, and what we're going to be using is in this equation 1. Yes. So again, my focus is at 0, 0. Directrix is y equals 8. So right now I don't have my k, but they gave me a way to find the focus. And as I mentioned to you before, the directrix is equal distance from the vertex to the directrix and the vertex to the focus. So knowing this information, I can know that my vertex is at 0, 4. So to find the equation of the focus, okay, they're giving me the directrix, which is 8. I just found out what my k value is, and I'm solving for p. So p is equal to -4. Yes, so now I plug this in, and now that I have all the variables that I need, I'll just plug it into my formula. And once I do that, I have an answer as x squared is equal to -16 times y minus 4. Okay. All right, let's look at this one. It says find the vertex, focus, and directrix of the parabola. Now, for these problems, again, I'll keep on using the formulas just so you can see where these problems are coming from. But hopefully, we can also, from our knowledge that we learned from pre-cal 1, we know what's happening to this parabola, right? When I look at this equation, I know that this graph is moving 1 unit to the right and moving 2 units down. Yes, and that's from what's happening to the x and y variables. Okay, but again, let's go ahead and use the formulas to find out what's going on. Okay, here, since x is squared, we have a vertical parabola. Okay, so when we have this equation, we can deduce all of the variables that we need, right? So our vertex, again, just by looking at this graph got shifted 1 unit to the right and 2 units down. So that's my vertex, 1, -2, okay, which are my h and k. Okay, so now that I have my h and k, I can find out what p was, right? So in my problem, they're saying that 4 times p is equal to -8. So what I need to do to solve for p is just divide by 4 on both sides, and I'm going to discover that p is equal to -2. Okay, so once I have this, I can use my formulas for the focus, and my focus is at 1, -4. Okay, and they're asking us for the vertex, which we got 1, -2. We have our focus, and now the directrix. So to find the directrix, again, I can use the formulas, plug in the values that I have, and I'm going to get that my directrix is at y equals 0. Okay. All right. Let's look at this next example. Find the vertex, focus, and directrix of the parabola. Okay. So there's several ways of doing this problem. Okay. So for us, again, it's obvious that our parabola is a vertical axis and pointing up. And the reason why we know this is because the x squared, we see directly the x squared has a positive. So that means that since x squared has positive, then we know that our parabola is pointing upward, right? So one of the things that we need to do is we need to complete the square in order to convert it into its new standard form of the equation. Okay, so let's go ahead and do that. Let's go ahead and to complete the square, what I want to do is I'm going to isolate just the x squared plus 4x. So to do this, I'm going to move that -6y to the other side by adding 6y on both sides. Okay, so when I do that, I have this x squared plus 4x equals 6y minus 10. So now I'm going to complete the square for the left side. Okay, so in order for me to complete the square, I need to know what the C value is. Okay, so to get the C value, I have asked for. So let me tell you how I did this. So what I did is I took that 4, I divided it by 2 and squared it. So 4 divided by 2 is 2, and 2 squared is 4. So for this problem to for it to be a perfect square, I need to add a 4 on the left, but I want to balance my equation. So if I'm adding a 4 on the left, I need to add a 4 on the right. Okay, so the left side is going to become x. By factoring, the left side is going to be x plus 2 squared. Okay, I'm going to combine my two like terms. -10 plus 4 is a -6. And then what I'm going to do is I'm going to factor out the common term, which is the 6. So when I do the factoring of the right side, I get the standard form of the quadratic equation, which is x plus 2 squared is equal to 6 times y minus 1. Okay. Now that I have it in standard form, I can answer what they're asking me. The vertex here, this graph got shifted 2 units to the left, 1 unit up. So my vertex is at -2, 1. Okay, I can find my focus by plugging into the formula, but since my focus is 6, and from my formula, the focus is 4p, so set 4p equals to 6, okay? So divide by 4 on both sides, I get p is 3 halves. So there's my focus. And the last thing that I need is to find the equation of the focus by plugging in the formula. And then now my directrix, the formula for the directrix is given by this. And then it's just solving for the y. So y is equal to a negative 1/2. Okay. And again, for most of these sections, it's just using the formulas that are given. So let's move on to 10.3. Okay, so 10.3 has to deal with ellipses. Okay, so just like the quadratic, we have two directions of our ellipses. Okay, now on the ellipses, we are we are classifying them whether they're on the major axis or minor axis. So your major axis is the north and south um, directions, which is your vertical, okay? And your minor axis is your east and west or your horizontal axis, yes? So this is the classification. And again, I'll do the same thing that I did before. So the one with the major axis, the case repeat, the one with the major axis as a um, vertical line, the H's repeat, yes? So we'll label this one, the case repeat as 1, the H repeats as 2, okay? All right, so let's look at, and um, something to know. The foci lie on the major axis, okay? Now there's a formula to find C, and let's see. There we go. So to get C, C is given by C squared is equal to A squared minus B squared. Very similar to Pythagorean theorem, but not, okay? You have a minus in between the A squared and minus B squared. It's kind of like the difference of squares. All right, so again, and this is where we have the foci. So in comparison to our parabola only had one focus. So our ellipses are going to have two focus. So the plural for focus, we'll use the word foci. Okay. So again, there'll be two foci the for the ellipses. Okay, whether it's on the horizontal or vertical axis, and these are the representations of where you would find these. Okay, and these are the values for C. Okay, so again, um, let's go ahead. Oh, so another thing that you will be asked on ellipses is ellipses have what's called eccentricity. What is eccentricity? Uh, eccentricity is you can think of it as the speed that an object is revolving around the ellipse. Okay, and this the speed or revolutions that an object can do around the ellipse is called eccentricity, and it's given by this formula. E for eccentricity is equal to C over A. Okay, so let's look at this example. It says find the standard form of the equation of the ellipse with the given characteristics. Have foci at plus or minus 4, 0, and my major axis length of 10. Okay, so if I look at here, the plus or minus 4, that means that I'm on the x-axis. So what that means here, that my ellipse is in the horizontal, yes, because um, the ones that repeat are on my horizontal, right? So again, which one are we going to be using? So we're going to be using our ones, right? So it's our major axis is the horizontal. Okay. All right, so I know what my K is. So to get the center and midpoints of the foci, again, we plug them in to our formula and we find out that H is also 0. Okay, so our major axis length is 10. So having that, we can find out what A is. A is 5. Okay, now that we have 5, using the information of our foci, okay, foci refer to the C values. Okay, so plugging these in okay, we can get our C value, which is equal to 4. And once we have 4, we can use the formula that I was given to us to find the foci, which is C squared is equal to A squared minus B squared, to get the other um, vertices, right? So the other point on our ellipse. So again, I'm using C squared is equal to A squared minus B squared. Um, Plug in what I have. I have the A squared. I have the C squared. Again, solve for B squared. So B squared is equal to 9. Please be careful when finding B. The formula, if you look at the formula for the ellipse, it's asking for B squared. Very common mistake students do is they take the square root of both sides and they put that as b. B is equal to 3. Do not do that. Well, b is equal to 3, but when putting it into the formula, okay, you're gonna put the 9. Okay, so just be very careful with that. So again, but if you were putting the 3 to the formula itself with a square, again, you would go back to 9. So that's an extra step. I tell students, don't take the square root. Just the problem is asking for b squared, just put the b squared. Okay. All right. So let's look at this other example. Now, on this one, they're giving us a picture, and just by the picture, we know that our major axis is the horizontal line, right? So we have an ellipse where its major vertices lie on the major axis. Yes. So here, we're going to be using equation 2. Again, very similarly, based on the points that are giving me, I know what H is, I know what K is. I also know the values for A and B. Um, so because here A is 5, again, my major axis is the horizontal axis. So, excuse me, vertical axis. So I have A is 5 and my B would be 2. Yes. If you see it here, my values that repeat are my horizontal axis. So B is 2. Okay. So again, now it's just plugging them into the formula. So when I do that, my final result is x squared over 4 plus y squared over 25 is equal to 1. Okay. All right. So next is sketching an ellipse. So let's sketch the ellipse given 4x squared plus y squared is equal to 36 and identify the center and vertices. So this particular problem is a very easy problem to solve. So if you recall, the equation of ellipse is a fraction for the x squared and a fraction for the y squared, but it's equal to 1. In this particular problem, it's equal to 36. But I can convert this into a standard form of equation of ellipse just by doing a simple process. Since I want this equation to be equal to 1, what I'm going to do is I'm going to divide both sides by that 36. So um, doing this, solving for this equation algebraically, the first thing that I'm going to do is I'm going to divide by 36 on both sides. And when I do this, you see that I end up with a standard form of the circle of for the standard form of an ellipse, which is x squared over a squared plus y squared over b squared is equal to 1. Yes. So here, what we need to find out is, well, which type of ellipse is it? Is it a horizontal or a vertical? Now, um, what is going to determine which one it is remember the major axis vertices have the larger number, right? The further the vertices are from the ellipse, that's what makes it the ellipse. So if I look at this problem here, 3 squared is 9 and 6 squared is 36. So 36 is a bigger number. So since 36 is a bigger number, my A is below the y squared. So what that means is that my horizontal axis is on the 1 over the y. I have a horizontal line since 36 was the bigger, was under the y. Okay, so um, let me put it here. So again, my major axis is the vertical, but my my ellipse is on its side. Yes, so I have h is 0 K is 0, A is 6, again, because it's below the y squared, my B would be 3, okay? So I can find my H and K. H and K is 0, 0. My vertices using the formula um, is going to give me 0, -6, okay, and 0, 6. Um, and then we have our graph, yes? So we identified our center and we identified our vertices. All right, so let's look at another example for ellipses again. This one says find the center, vertices, foci, and eccentricity of the ellipse. Again, I'm going to look at this problem and I see that 25 is a bigger number between 16. So 25 refers to A squared, and 16 refers to B squared. Okay, so, and I also know another piece of information. I know that this ellipse got shifted 2 units to the left and 3 units up, which will allow me to also get my H and K. So let's go ahead and get these values. Okay. Um, so here, as you can see, my H got shifted 2 units to the left, so it's a -2. The K got shifted 3 units up, so K is 3. Again, A is 5 because 20 the square root of 25 is 5, and B is 4 because the square root of 16 is 4. I'm going to use my formula to find the C. I'm going to use C squared is equal to A squared minus B squared. So C is going to give me equals to 3. So I'll go ahead and place it there. So now I can find what they're asking me. So again, my center is at H and K, which is -2, 3. Um, my vertices, plugging them into my formula, are going to be -2, -2, and -2, 8. Okay. My foci, using the formulas given to find the foci, I am going to get -2, 0, -2, 6. And the eccentricity, the formula for the eccentricity is E equals to C over A. So C is 3, A is 5. So the answer is E is equal to 3/5. All right, let's move on to 10.4, hyperbolas. Okay. Um, and I did forget to mention again, but this is the review. All of these um, graphs, the parabola, the ellipse, and the hyperbola all come from our cone, right? This chapter is called the conic section because all these shapes are are shapes that are taken from a plane cutting through a cone. Okay, so on this one, the difference between hyperbolas and ellipses and parabolas is that for the hyperbolas, we're looking at the whole aspect of a and the two hemispheres of the cones. So we're looking at whether the cone is pointing upward or whether the cone is pointing downward. Hence, that's why we have two branches. Okay, so we have our first one that we have here on our left. Um, we have the two branches are um, technically on a horizontal line, but what we have is we have a transverse axis. Yes, our horizontal line here is called our transverse axis. Okay, now um, the hyperbolas are also going to have asymptotes that define how wide these branches open. Okay, so this is the formula to find the asymptotes. And very similarly, when we have the branches that are opening up and downward, what we have is a transverse axis, which is a vertical line. Okay. And again, they're giving us a formula to find the asymptotes. So here again, on our horizontal transverse axis, the K's repeat. For the vertical transverse axis, the H's repeat. We're going to call this one 1. We'll call this one 2. Okay, so let's go ahead. To find our foci, we have a new formula. Please don't mistake this one with With the ellipse one, this one is c squared is equal to a squared plus b squared. This one looks exactly like, excuse me, like Pythagorean theorem. So let's go ahead and do this example. It says, find the standard form of the equation of the hyperbola with vertices at 0, 2, and 4, 2, and the foci at negative 1, 2, and 5, 2. Okay. So these are my vertices. These are my foci. So which form is it? And do we have a horizontal transverse axis or vertical transverse axis? So let's look at these. So which ones repeat? So if we see here, what is repeating is our case. So let's go ahead and plug what we know. So we have our H, we have our K. Um, we also, um, from the vertices and the foci, we can go ahead and calculate what those are. So A is 2, okay, and C is 3. So what we're missing is B. So again, we're going to use C squared is equal to A squared plus B squared to go ahead and get our B. Again, I wouldn't go this far, but let's just go ahead and get our B just so we can keep on practicing our formula. Okay, so B is equal to the square root of 5. So let's go ahead and plug all of this into our formula. Again, the square root of 5 squared is going to give us 5. So that's why I don't like going that far. But anyway, it gives me to my standard form of the equation of the circle, the hyperbola, which is given by x minus 2 squared over 4 minus y minus 2 squared over 5 is equal to 1. Okay. Um, so another a piece of information, I'm not, just in case we don't get to see an example of it, but one way that we know that we are dealing with a hyperbola is that our our fractions on the left are being subtracted. If you saw for my ellipse, uh, the fractions were being added, but for hyperbolas, if they give me a hyperbola in standard form, and I see that the two fractions are being subtracted, it's gonna tell me automatically tell me that I am dealing with a hyperbola. Okay? All right, so um, let's move on to the conversion of polar to rectangular points. Okay, so here, okay, a rectangular point is given by the radius and the angle. Okay, this refers to our x and y. So to get our x, we're gonna multiply our radius times the cosine of theta. Again, remember from trigonometry, cosine refers to the x values. So very similar to get our y value is going to multiply our radius times sine of theta. Sine of theta refers to our y value in trigonometry. So let's go ahead and find what r and theta are. Okay. So again, in our polar point, they're giving me the radius. The radius is -2. Um, and they're giving me the angle, right? The angle here is 7 pi over 6. So if I want to convert this to rectangular points, okay, I go to my unit circle and I find out what are the x and y values for 7 pi over 6. And if I see here, 7 pi over 6 is in radian form. The degrees of 7 pi over 6 is 210, which refer to the x value of square root of 3 over the negative square root of 3 over 2 and negative 1 half. So to find our rectangular point, again, I needed these 2 points. Let me get my x and let me get my y. So x is equal to -2 times the cosine of 7 pi over 6. Um, 7 pi over 6. Um, and for the x is negative square root of 3 over 2. A -2 divided by a -2 is going to be a +1, and 1 times square root of 3 is square root of 3. Let's get our y. 7 pi over 6 is -1 half. So -2 divided by -2 is 1, and 1 times 1 is 1. So my rectangular point for this given polar point is the square root of 3, 1. Okay. All right. Let's do another one. Convert the regular. Let's do it backwards now. Let's go from regular to polar. Okay. So in this particular problem, they're giving me the x and y, right? So we need to know what we want to find out. What is the radius and what is the angle? Okay. So again, to find the radius, we're going to use Pythagorean theorem, right? Or r squared is equal to x squared plus y squared. But on this problem, we went ahead and solved for r already, so we can just plug it in. They're giving us the x and y. So and to get the angle, we're going to use tan of theta is equal to y over x. Yes. So then it just becomes plugging in. So let's get our radius first. Okay. So we know that by this point that they're giving me, that x is -1 and y is square root of 3. We're in quadrant 2. Okay, so we need to add pi to the arctangent of theta. So just keep that in mind. So let's go ahead and get our radius by plugging in our values. And we find that our radius is 2. So let's find tan of theta. Tan of theta is equal to the square root of 3 over -1. Okay, so tan of theta is equal to negative square root of 3. So if I do the arctan of um, theta, what I'm going to get is theta is equal to negative pi thirds. Okay, so again, because I know that I'm in quadrant 2, I need to add pi to this inverse angle, and I'm going to get that my angle that they're referring to in quadrant 2 based on these 2 points is 2 pi over 3. So now I can write my polar answer. My polar answer is the radius is 2 and the angle is 2 pi over 3. Okay. All right. So let's move on to finding parametric equations for a graph. So let me just read what you see here. We have parametric equations defined as a curve by expressing both x and y as functions of a third variable called the parameter, or commonly t. Instead of writing y directly as a function of x, we have this. Okay, so this is what you're familiar with. X is equal to f of t, and y is equal to g of t. Okay, so we can represent these parametric equations by doing these examples. So let's say that I am given x is equal to 4t squared minus 4 and y is equal to t. Okay, so what they're asking us is find a set of parametric equations for the given graph. Okay, so to produce the graph, okay, what we want to do is me give you an example. So we're going to set the parametric equations to represent the graph of y is equal to 1 minus x squared using each of these parameters. So let's do A. T is equal to x. So our solution to obtaining the parametric equations, x is equal to t, y is equal to 1x squared. So this is 1 minus t squared. Okay. So to show that the curve represents the parametric equations, we'll show you the graph of this, right? So this is our graph for these parametric equations. Okay. All right, so let's look at this. Find a set of parametric equations represent the graphs of y is equal to 1 minus x squared using each parameter. Again, we're replacing y with t. So first, what we're going to do is plug in the values for each of the equations, right? So here is what we're doing, okay? And once we solve, we have 2t minus t squared, okay? So again, this is just a review on how we're getting our parametric equations, okay? Oh, so, I finished really fast. Does anybody have any questions? Patricia, are you still in the room?
Yes, sir. Thank you.
Did we have any students?
No, we don't have any questions, but that's okay.
Okay.
We can go ahead and wrap up. All right.
All right.
Okay.
Thank you so much. And
Thank you, Mr. Carrizales, for your presentation.
My pleasure. Thank you, guys. Have a good weekend. We have one more week left, so we're almost done.
Almost done.
Almost done. Thank you guys for all your help.
Bye, guys.
Thank
right,
you.
Have a great weekend.
You too.